Okay, so good morning, all, and welcome back to the session. Friends, in the past few sessions, what we have discussed, we have gone through with LangChain in detail, and we tried to build the chatbot based upon the LangChain. And what are the basic steps once we have created the RAG chatbot? So data loader was there in order to load the data. Then after loading it, we have given it to the splitter, which has generated the chunks based upon the conditions what we have given over here. Now these particular chunks are given to embedding model. Embedding model, and then from embedding model it is given to the vector store. Vector store. So in the vector store, we are having all the chunks based upon this particular data. Chunks, documents, you can take it in anywhere. Now, from there, like we are passing it to the large language model, and we are providing our query as well. Query, we are going to write it over here. Query is given to, like, it will be also passed from the embedding model, and inside the vector db the search is being happening, what I can say, similarity search. And then the docs what we are getting based upon the similarity search, these are given to the large language model along with the query that we are having, and the prompt. Prompt is also given to the large language model. So based upon this, what we are able to say, we are able to get the outcome from the large language model. That is perfectly fine. But what will happen over here? Uh, the large language model's output that was generated, it might be possible that is not fully correct. Okay. There is a word LLMs indeterministic nature. LLMs are having indeterministic nature. What it means, like if you are providing one query or two queries to the large language model, so both of the queries will be having the two different answer. It is same as the human beings. Say if like we are asking 10 question, 10 different 10 same question to 10 different persons, so they will provide the different answer. And it might be possible if I'm asking 10 questions, similar questions to one human, uh, he or she will not be able to provide the same answer to all of the questions. Okay, so there might be some here and there with respect to the wordings and all. So that is the case, and we are mimicking large language models as digital humans. Digital humans, as human are having the characteristics to uh, get the input and process it and provide the output. In the same fashion, what we are having the large language models, and what I can say, these are the digital humans. Okay, now the output which is being generated over here, that is not up to the mark, that is having certain hallucinations and all. If you haven't provided the prompt correctly, if the query is not proper, this particular query is not proper, if the chunking strategy is not is not proper, then you will be able to get the incorrect output, or what I can say, hallucinated output. LLM will provide the output, but it will depends upon you how this particular output is going to suffice in your requirement. Okay, so what I can say, how to optimize, how to optimize the the output. Okay, so what I have mentioned over here, uh, better chunking strategy, and how the chunking strategy can improve the output. Can anybody tell me?
Yeah, based on actually chunking, we can decide the like index size. Like if we are going to higher chunk, like index size will be low. If we are giving the lower chunks values, so index size will be high. So if we are giving the lower chunks value, LLM can provide the hallucinate output because LLM needs to work on large data. So if we are going to uh, if we are going to reduce the chunk size, so indexes will be small indexes will be there,
Mhm.
and LLM needs to work on particular indexes only.
Okay, so
Understanding.
let me rephrase it a little bit more. So, guys, what is being happening once we are performing the chunking? So we are having the chunk size and the chunk overlap. Huh? Correct? Are you able to recall, all of you? Chunk size and chunk overlap.
Yes,
Yes.
yes.
So
Perfect.
overlapping also plays some role over here. What?
Correct. That's what I want to say.
Yeah.
So chunk overlap is going to to build a relation between these particular chunks, right? Chunk overlapping, say if I'm having same information into two chunks, that means like these chunks are having the relationship between each other, huh? Correct. if
Correct, correct, correct.
if same data is there in two chunks, it means like these chunks are having relationship between each other, among each other, huh? Now if the chunk overlapping is say less, and we are performing the search based upon the that particular search, it might be possible in first chunk we are having the information, okay, and the second chunk we are not having the information, uh, and what this particular similarity search will do, it will fetch one chunk only, and that will be given to the large language model. But our expectation was like as these two chunks are having the relationship, because like I want the complete answer. You can take it in this particular way. Let me try to explain it with example. Okay, so say I'm having say lang chain is a good framework, and uh, with the help of it I can build Gen AI application. Okay, and I'm having say chunk one. This is the chunk one, say, and I have given say the overlapping. So this is the overlapping, and it is mentioned like Gen AI application, and it is able to it can build strong RAG solutions. Huh? I'm just like trying to mention in such a way that you will be able to understand. Huh? Okay, so this is chunk two. Huh? Now the search is being the query was like what is lang chain? Huh? Okay, what is lang chain? So based upon that particular question, it is able to identify, yes, in the chunk one, I'm having the lang chain, and this is the, you can say, related chunk. in order to provide the output. But this particular uh, the line say this is the complete, you can say, sentence, huh? What I'm looking for this particular output, huh? I'm looking for this particular output, correct, from the large language model, huh? But but in the similarity search, this particular chunk is not, you can say, search, and it has given this particular chunk only to the large language model in order to frame the answer, right? Okay, so what is the issue? Because of this particular overlapping, the system is not able to identify that this is also related to this one, huh? Right? And it is not given to why, how the system is not identified, because it is not, you can say, coming inside the similarity search, right? Correct. So the output will not be up to the mark. So what I can do, I can have the better chunking strategy. Like probably I need to increase the overlapping or increase the chunk size. Huh? So that I will be having the complete output, huh? Correct output. Are you able to understand? All of you? Simple one.
So,
So
sir,
both things we
highly,
need to increase, chunking and overlapping, right?
Yes, that will depends upon use case to use case. Huh? That will depend upon use case to use case. It is not like say I need to increase the chunk size, or I need to increase the overlapping. So based upon, like, you will be performing, you will be going through with the benchmarking and the outcome that you are getting from the large language model, and you need to, like, if you are the SME, then you will be able to get, yes, this is the correct one, I can proceed with this particular output. Or if you need to further refine it, you can change the chunk size or increase the overlapping, no? So at that particular moment you will be able to get, and there will be a time when you will say that this is the correct one, I can proceed with this one, no? So this particular chunking strategy is playing a critical role in order to have the correct output from the large language model, because it will decide what can be searched, and after searching, that can be fed to the large language model in order to generate the output on top of that, huh? Correct.
So basically, what I can understand, like we cannot say like in one go I will able to get the output. Maybe I have to give some multiple iteration by
Correct.
reducing or increasing the chunk size and overlapping, and
Yes.
depend on that. Once I got the final output, then only I can decide like what should be the chunk size and what should be the overlapping, right?
Yes, and it will depends upon it can vary domain to domain.
Of course.
Okay. So this is, you can say, even like sometimes you need to increase this particular these particular documents
but
as well.
sir,
You need to increase the value of k as well, huh?
but sir, generally there should be like any specific value of chunk size and chunk overlapping, like golden parameters kind of thing. Is there any specific like
A
default value?
golden parameters are coming once we are working onto a specific domain. These particular things are not related to domain. It can be applied anywhere.
Okay.
Okay.
So chunk size and the over chunk overlap depends on particular domain wise. Like
Yes.
medical domain, it will be different. Telecommunication, it will be different, or software, it will be
Y-
different.
Yes. 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 Okay. So this is based upon chunking, how to optimize the output. So first, like, better chunking strategy. Then second one, what I can have, what I can do, what else I can do?
Refinement of prompt, I think.
Hmm, refining the prompts, and we will discuss in detail onto this particular step and like how to refine the prompt, but I'm going to discuss about certain other things. Okay, so refinement of the prompt, and probably with the help of refinement of the prompt, what you can say, like what the query we are going to, what are the instructions that I'm going to provide to the large language model. These instructions should be smart enough in order to get the output, or I can, based upon these particular instructions, I can align the large language model in order to get the output. Okay, so we need to refine the prompt uh, in a good manner, and we will discuss in detail about these particular things now. Then over here as well, say if I'm number of dogs, number of dogs feed it to LLM. Okay, so say if you are feeding 5 documents, then the LLM is going to tackle uh, or create the output, prepare the output based upon these particular 5 documents. It might be possible like you need to provide somewhere 10 documents. In my case, I'm giving 100 documents or 100 chunks to the large language model in order to get the output. Okay, so that particular parameter, or you can say documents which are searched and given to our large language model, that is also playing a critical role. Okay, and you are able to correlate probably, is it?
Yeah, it's about the retrieval parameters, search type and KW arguments,
Yes,
right?
yes.
And
Then
also, is it
searching.
also depends on vector DB model that we are selecting for particular field?
So at that moment, like opting a vector DB, that is depending based upon like the type of database, and it can play a role like onto the latency. What it means, say some databases which are working in such a way that they are going to just search, perform the similarity search and then give it to the large language model, and like how many dimension that they can able to handle, that is the one thing. Second is like the backend mechanism of those particular databases, like is it able to work in real time, or is it able to store the data, is it able to, you can say, uh, provide the query with low latency. Yeah, so with respect to those particular things only, uh, what I can say, we will be able to utilize a DB, correct? Utilization of DB depends like how much latency I can afford. So from the latency perspective, I can have the database. I can change the database. Correct? Vector DB basically. Yeah.
Yes.
So searching strategy, like we have gone through with different searching strategy, that is MMR and similarity search with threshold. Okay, that is also able to, you can say, change the output. Correct? Is it fine with you all?
A searching strategy, is it similar to the refinement of prompt, or I'm confusing about this term searching strategy?
Searching strategy, what is the meaning of like how you are going to perform the searching based upon the similarity search?
Okay, similarity search and
Searching strategy in vector DB, na?
Yes, searching in the vector DB. Correct. So we are having two strategies, like which one we are
एक
going to
चीज
work?
इसमें एक चीज और भी हो सकती है कि मेटा डेटा है और उसको भी अवॉइड किया जाए, वो भी हेलोसिनेशन का कारण बन सकता है ना?
Yeah, that can be added. Okay. So in general, what I can say, these are the things what we need to, you can say, think in order to optimize, like in order to get the correct output. But uh, if we talk about the issues, these particular things are in general. Now we are going to start like what are the different things that we can do in order to optimize the RAG. So first we need to understand the issue, like uh, what are the issues that we can have inside the large language models, inside the RAG chatbots. So issues in RAG chatbots. So broadly, like there are two issues. First one is generation level issue, and second one is retrieval level issue. Retrieval issues. Okay. Generation, it means what is being generated. Okay. The LLM has provided the certain output, and what you need to do, you need to check like how you will be able to trust onto the output. How you can trust on the output given by LLM. Okay, so if you are having the generation level issue, so first one is how you can trust that particular output. That is the first thing. Second is how you can optimize it. How you can optimize it. So friends, like generation level issues, in order to tackle the generation level issue, this is very easy stuff. Easy stuff. So these are the two problems only. Like once you are able, you are facing the generation level issue, like the output that is given by the large language model, if that is not correct, so how you are going to handle this? So if the generation level issue is there, and you are not able to trust onto the large language model, the first thing that you can do is add the citation information. Information. Citation information. What is the meaning of this? Say if some output is given, you just want to take the reference of that particular output. And in the previous session we have seen like how to add the reference. Like the large language model has provided certain output, but how I can trust it? I can take the source information which is being utilized by the large language model in order to prepare the output. So what I can say, I can get the reference or I can have the citation. It means like I will be having the source of the information from where I'm able to get the data. Okay. And citation is something, uh, say Langchain is a book, say Langchain overview. This is the book, and it is the place somewhere, and page number 1, 2, then 10, and then say 15. These particular pages are utilized in order to provide the output. So this is nothing but citation. Probably you are able to understand. Is it?
Yes.
All of you? Generation level issue, like how you will be able to trust onto the output which is provided by our large language model. Just take the reference with the output, and then you will be able to trust it. Like LLM can hallucinate, but how you will be going to trust on large language model that whatever output it has given, it is the correct one? So what you can do, you can ask the source information. What is the source of information for this particular output? The source of information will add trust onto the large language model. What I have mentioned, LLMs are having indeterministic nature. Okay, we can't trust onto the LLM output. So we need to have the human intervention over here, and we can ask the citation or the source information. So that can be tackled. This particular problem is tackled with the help of this particular solution. Now, add citation or reference information. We have seen how to add the information now, how to add the source of information now. Okay, so this is perfectly fine. Now, how you can optimize? So, if you can provide the better prompt, if you can provide the better prompt, then you will get the better answer. Correct? Is it fine? Better prompt, better answer.
Correct. We can restrict the prompt.
Okay. So that is perfect. So on to the generation level issues. These are easy to tackle, and this is the issue what I can have. And these, for this issue we are having this particular solution, and for this particular issue we are having this particular solution. In order to minimize the generation level problems. That is perfectly fine. Now what happened with the retrieval level issues? Retrieval issues means whatever the documents over here, if we are able to see whatever is being retrieved from here, from the large language model. Okay, if the issue is over here, we have seen generation level issue is lying over here. Just focus on to the cursor. Okay, generation level issue is available over here, and retrieval level issues are available over here. Okay, retrieval level issues are available over here. So whatever is being retrieved from the, you can say, vector store, what you can do, you can you need to, you can say, do the optimization on top of that. Correct? Correct?
Yes, yes.
Okay. Now, if we are performing the optimization, just a minute, give me a second.
So retrieval issues related to whatever document we fetched from vector DB. We are talking about that type of issues, correct, sir?
Hmm. Okay. So these are the two issues. Now, handling the retrieval issue is really the tough thing, and there are three levels of solutions. Once we are talking about the retrieval issues, first one is, say, query transformation. Query transformation. Second one is query routing. Okay, and third one is indexing. These are the three techniques what I'm going to perform in order to you can say improve the retrieval. Okay, so once I'm going to talk about the query transformation, what is the meaning of this? So translate query transformation means I'm going to work on to the query. Like if the retrieval of the documents are not up to the mark, what I can do, I can rephrase this particular query. We in the over here we have rephrased the prompt, right? In order to get the proper answer. But once I'm having the retrieval issue, I need to work on to this particular query part. So query, it means translate translate the user question in some other way to improve the retrieval. To improve the retrieval. So say over here, let me take an example for this. If I say a lang chain, the question is say lang chain. So I will get on top of this, I will on this query, what I can say on this query, I will get docs wherever lang chain is available. Okay, so what I can do, I can rephrase it a little bit. Say what is lang chain, okay, and share its benefits. Correct. So this is this particular query. Probably, definitely, the large language model will be going to provide the output based upon this particular query. Okay, it will provide the output, but will that output will suffice? Will that output suffice your requirement? Definitely not, because it will be having uh, hallucinated, what I can say, hallucinated output, or that is because of the indeterministic nature of the large language model. Okay, whatever it is smart enough in order to, you can say, get what is LangChain and whatever the information related to LangChain it is going to provide. But that particular output will not be able to suffice my requirement. So what I can do, I can rephrase or translate the user question in such a way that I will be able to get the output correctly. So over here, this is the question that will be asked to the large language model in order to get the correct output. Probably you are able to get it. And how it will happen? It will happen in this particular way. The lang chain is given and it will be passed through the generation model, and it will generate this particular question. Okay, it is something like done with the help of this particular generation model. Okay, so LangChain, this is the you can say uh, this question is not, you can say, correct, not correct. This is the bogus, you can say, question. What it is given to the generation model. What the generation model will do, it will rephrase or translate the question in the better way, and then it will be going to perform the similarity search and all from the database, and we will be able to get the required docs, and those particular docs will be able to provide the correct output. So the question will be given to the generation model, and that particular generation model will provide the correct output. Or what I can say, this is a raw query, and this is a refined query. Fine. Is it fine with everyone?
So this generation model is a kind of a new model we will be going to use, huh?
Correct, correct. That we will be going to use.
Okay.
Right.
So it's a basically LLM that are designed on the human writing behavior. Or
This is
What is the
based upon the technique what we are
basic
going to
behind this?
use. Like will be going to add this particular technique. Right, we will be passing the query from the generation model. Okay, at this moment, what we are doing, we are passing the query directly to the embedding, you can say, model, and embedding model is going to perform the embedding and then similarity search. Now what will happen, this particular query will be passed from the generation model, and then it will be given to embedding, then vector db, similarity search, and then llm. So the flow will be like that.
So the generation model is also, is it also working like based on distance pattern or something?
Yeah, that we will see, no need to worry. Okay, correct. I will explain like once we will be having the practical session on this. Today we are going through the theory part only onto these particular things. Correct? Is it fine?
Yes, sir. Yes, sir.
Is it the same thing that sometimes we on the chat GPT we put some code and in the last we just say explain. So this will rephrase our query with this kind of generation model, because sometimes I also observe I put just some stupid kind of text there, but it's check my intention, what I want to know from this code. So that's happening with the help of this generation model.
Yeah,
Is
that
it?
might be the case. Okay. So over here, guys, what is being happening? Say instead of like probably you have faced this particular situation, say if we are not typing correctly and still we are able to get the correct output, it is able to understand, the large language model is able to understand, correct?
Yes, yes.
So that is the, you can say, simple stuff which is being happening internally, yeah. Right? Whatever you are going to provide, generation model is nothing but a large language model, to be very frank. So whatever you have seen previously with respect to the different models, so same stuff is being done over here. And the normal process, what it will be like, what it will do, it will first uh, reformat this particular query. Yeah. Okay. Re, and reformatting means like it will try to apply the formatting, say the words and incorrect words will be converted to the correct one. Then it will be going to, you can say, decomposer is there, and then it will be given to the structured query generator, like uh, generation model. We will see like what are what the internals of the generation model, no need to worry. But the main thing is that what is being happening, it is the large language model, and like which is trained onto the less amount of data in order to generate the new query. And the main intent of this, like it will be taking the raw query and provide the refined, you can say, query once we are going to pass the raw query to the generation model. So almost the same stuff, but certain things are here and there. But that understanding or like going through in deep with generation model, that is not even like required over here. You just need to understand what generation model is doing. Generation model is just going to convert or translate your query into the more meaningful, you can say, sentence, what I can say. Okay. It is into the more meaningful intent. Correct. So you can take it in this particular way. Say I'm having one query. Say my name is Ashok Kumar. I am learning Gen AI, and at the end, I ask what is Gen AI, okay, or what is the LangChain, LangChain. So over here, the generation model is smart enough in order to remove the unwanted data. Like, so over here, the user has asked what is lang chain. So is this particular information which is available inside the query, is it making sense? Hmm? The highlighted context, is it making sense?
Correct. Correct. This is additional information, no mean of that type of
Huh.
information.
So, so what the generation model can do, it will just translate it to probably what is LangChain, right? And say if like the user is searching over here, the similarity search will happen based upon say my name is Ashok Kumara. So probably it will be able to identify certain data from where I'm searching, right? And if that data is or certain similarity is there among this particular data, then that will also be clubbed into the output, correct? And if that is clubbed into output, and my ask was what is lang chain, and it has given me the information with respect to this as well, okay, and that might not be the correct one, right? So the generation model, what it will do, it will generate the query into the refined version of it, correct? Hmm?
Correct. Correct.
Yes, yes.
Okay, so this is the query transformation. We will be having the multiple techniques inside the query transformation. Uh, I have just explained like what is query transformation now. And there is another you can say stuff like say okay, we will discuss that in the variation multiple variant of the transformation, query transformation. So it might be possible like let me give you one hint. Okay, so over here, say whatever we are being generated, say we are getting the documents over here, doc one, or say post post similarity search. I am getting the chunks or docs. Okay, so what I can do, I can have some scoring mechanism. I can have some scoring mechanism to get the more chunks, to get the more relevant chunks. So where I can do this particular stuff inside the like whatever we are getting from the vector store. So if I can post similarity search or during similarity search, not the post, during similarity search, I can add during similarity search I'm getting the chunks or dogs. I can have some. Okay, that is perfectly fine. During similarity search, I'm getting the chunks or dogs. So over here, I'm getting the chunks or documents. So if I can add a mechanism with the help of what I will be able to get the chunks which is having higher relevancy with respect to this particular query. Okay, so that can be done with the help of query rerouting. Oh, sorry, query transformation. So I will update the query in such a way that I will be having more relevant chunks fetched, which are fetched from the vector store. Let me explain it once again. So guys, what is being happening from the vector store? I'm getting the documents or chunks. Okay. Now, fetching these particular chunks from the vector store are based upon what? Based upon this particular query. Correct? So once I'm fetching these particular documents from the vector store, okay, if I can have certain mechanism over here, based upon what I will be able to get the more relevant chunks only, which I can pass to the large language model. So that particular mechanism will also improve the retrieval, huh? Or improve the or minimize the retrieval issue or improve the retrieval success.
But I think that is already happening in similarity search, na?
That is happening, but how we can optimize it further, that we are learning.
Okay.
Okay, is it happening? That is perfectly fine, but we are going through with advanced drag techniques, huh? What I can say, this is nothing but advanced drag, huh? Advanced drag. Okay, so previously we have seen just writing the query and pass it to the embedding, then chunking, embedding, and then chunks will be there and give it to the large language model. But at this moment, what we are saying, the query will be given to the generation model in order to have the refined query that will be like proceeded with the rest of the operation. Correct? And why we are doing this? In order to optimize the retrieval, in order to improve the retrieval success. Huh? Correct? Is it fine with everyone? Query transformation?
Yes.
Say yes or no, guys.
Yes, yes.
Yes, yes.
Okay.
Yes, yes.
Yeah. So there are different techniques inside the query retrieval. We will be learning those particular techniques. But let me try to explain the query rerouting. So it might be possible, friends. Say we are having say user query, and what we can what is the normal way? Okay, so database, and say I'm having prompt, and what I mentioned, say inside the I have given the user query, and I ask something, say tell me the count of this, huh? Okay, count of say employee, tell me the count of employee. Okay, um and don't worry about say how I can be able to get the count of employee. Say if I'm having say CSV data and all, so that we will learn, but try to understand the context, huh? So what it will do, it will check this particular you can say query, and it will be given to the prompt, and prompt will check the details and all, and it will try to fetch the required details. Now say this particular prompt will go to this particular database in order to get the correct output, and that will be given to the large language model in order to provide the output to the user, in a more you can say refined way. Okay, so after getting this particular count, the large language model will add the explainability onto that particular data, and user will be able to get up. So say tell me count of employee, so it can say 14 or 15 now. So 15 employee. What LLM will do in this organization, there are 15 you can say employee. So it has added the explainability to that this particular you can say output which we are getting from this particular database. So what query rerouting says, it might be possible in the normal scenario, we will be having the different prompts and different database. Say prompt 1, then DB1, say prompt 2, so DB2, database 2, prompt 3, and say DB3. Okay, it will be say this particular flow, and uh, say prompt. These are the prompts, and the user query is over here. User query, then query routing. Okay, so over here, the user query is based upon the user query. At the query routing, it is going to decide uh, which prompt is utilized for this particular, can be utilized for this particular query, and based upon the prompt, say which DB will be working in order to work onto that particular prompt. So this is done with the help of query routing. So we need to route it to the proper prompt and proper database. So we have seen single query and single prompt and single database related stuff. Okay, but it might be possible, like we will be having the different, you can say, prompts. Okay, we will be having the different databases or data set. You can take it in this particular way, like over here we are having sales data, over here what we are having, say, R&D data. Okay, R&D data. Okay, over here we are having, say, uh, engineering records. Okay, over here what I can say, the HR data. Okay, so based upon the user query, the query rerouter is going to understand which prompt will be utilized for this particular data, and based upon the prompt, which database I need to refer. Correct? It might be possible, say, we are using, say, Chroma DB, we are using Pine, Con, we are using Postgres, SQL. Okay. So depends upon the prompt, depends upon the user query. So query routing is going to take place over here, and respective prompt and respective DB will be selected in order to provide this particular output. Right? Hope you are able to understand the context. Query routing.
Yes, sir. Yes.
Okay.
Okay.
Multiple prompt, multiple DB, but which one we need to select based upon the query only. The user who is typing the query is not having the information which DB is mapped with this, or which prompt is mapped with respect to this particular query. He just come and ask the question, but who is going to decide? We as a developer are going to decide. Okay, like this particular query will be routed to which prompt or which database. So that will be configured, and we will see during the practical, like how we will be able to route a query to the different databases, or to query to the two different databases, right? Correct? Simple, huh? Fine so far?
Correct, correct.
Yes.
Okay.
Okay.
So the third technique, in order to perform the retrieval, in order to reduce the retrieval issue, is nothing but indexing. And it's very simple that like what to index. and when to index, what I can say, when to index, what to index and when to, what is to index and when to index. So these are the things which are decided by the indexing, and during the practical, you will be able to understand it thoroughly. We are just applying the indexing, you can say, strategy in order to improve the retrieval. Correct. Indexing, you can take it in this particular way, like we are having a book, and inside the book, we are having the indexes. Say chapter one is there, and these are the subtopics, and this is from first page to say 50, from 51 to 80. We are having chapter two. Okay, and this is utilized in order to, you can say, improve the the information what I can search inside that particular book. In the same fashion, we will be having the indexing over here in our rank chatbot, and we'll implement it in order to improve the retrieval, in order to minimize the retrieval issues. Correct? We will see practically. Okay.
So indexing will be done with the help of splitters.
Splitter work is done over here. Okay. Now we are talking about at this moment now. Okay.
Before LLM.
Retrieval side.
Yeah.
Correct.
Okay,
It's a,
okay, okay.
is it the part of vector DB, right?
Yeah, certain vector databases supporting the indexing mechanism. Correct.
Okay.
We'll see in more detail, but at this moment, you just think like indexing is a technique which is going to improve the retrieval, and the thing is, the tagline is what is to index and or what to index, what I can say, what to index and when to index. So these are the two things what I can have once we are talking about the indexing. And once we are having the practical, you will be able to understand it thoroughly. Okay. Now, Curie transformation. Once we're talking about the Curie transformation, this is the major, you can say, portion, and Curie transformation is being done with the different approaches. Okay. So Curie transformation. Inside the Curie transformation, we are having the multiple, you can say, techniques. So the first one is Curie rewrite. Okay. So once we are talking about the Curie transformation, the first technique is rewrite. Curie, and we have discussed about Curie rewrite. Curie rewrite, and with the help of name itself, we are able to understand that we are rewriting the queries. Okay, so this is the first technique, Curie rewrite. Curie rewrite, that is convert the query into refined version of it. Okay, so example, you can take it in this particular way, like this is the example, and defined version, it can be what is LangChain. Let me try to show you something which is available onto the internet. Uh, this is responsible AI. Okay, so just have a look over here. Actually, right. I just want to show you one diagram. Diagrams are not there. Okay, so over here, let me try to prepare. So okay, we can utilize this particular stuff only. Yeah, like say this is the generation model, or you can say query rewrite, which is being happening over here. So we will pass the data query rewrite and query, and then we will be having the refined query. Okay, refined query, or what I can say optimized query as well. That will be going to provide the better context. Okay, context like the search documents which are given to the large language model in order to prepare your answer, in order to provide the output. This is nothing but the query writing. We just passing it from the generation model, and it will be converted into the, you can say, different, you can say, uh, different different refined queries. Okay, probably I can show. Okay, in the practical, you will be having the better clarity. Yeah, like we will be passing it through the LLM, and will provide the instructions, convert this particular uh, query into the refined version of it. Let me try to show the prompts. At that moment, you will be having the better clarity. Yeah. So, query rewriting prompt. Okay. So system, you are a helpful assistant that generate multiple search queries based upon the single query input, right? Perform query expansion if there are multiple common ways to phrasing the user question, or the common synonyms for the keywords in the question. Make sure the return multiple versions of the query, right? what we are doing over here? Are you able to understand, all of you? The query is given to the LLM, and then we are getting the refined query, right? Guys, are you able to understand?
Uh, Actually, after prompt perform query expansion, this instruction we have given in prompt only, na?
Yes, this we have given inside the prompt. This is like something over here. We are generating 3 versions of it.
Okay. Inside the system message, only we have given that type of query rewrite condition.
And these particular things will be given to the large language model. Okay,
Okay.
so you can take it in this particular way. So the next one is multiple. This is the prompt for multiple query. Okay, let me try to mention over here. The second one is multiple query. Multiple query. So what is being happening over here? Say over here, say this is query one, and it will be passed from say multiple query, and say over here I can have query one, query two, three, or what I can say query underscore new, which is being generated. Otherwise it will create confusion. Okay, so based upon this particular query, I passed it with the multiple query. You can say the large language model, basically generation model. And what I can get the multiple sub queries. Now based upon these particular queries, I will be able to get say over here what I was having previously. Say I have given k equal to 4. Okay, k equal to 4. This particular value I have set up. Now, issue was like say if I'm having query 1, and based upon that, like I am getting the 4 documents, but those particular 4 documents were not able to provide me the correct output. So what I have done, I have used the another technique, that is multiple query. So multiple query is going to do what? It is going to convert the given query into the multiple query. Now these particular queries, say query new one, and it will be like this. And query two. Just try to understand, friends. And query three. And based upon say query one, we will be having say context one, context two. Context means like doc one, doc two, doc three. I have taken the value to 4. K equal to 4. So I will be having 4 document over here, correct? With respect to the query 2 as well, I will be having the 4, you can see, documents. And with respect to this as well, I will be having the 4 documents, correct? Context 1, context 2, context 3, 2, 3 and say 4. Okay. Now I will be having, friends, 12 documents, 12 documents, and I need to choose, okay, I need to choose 4 documents out of these 12, right? So say I'm going to, I have taken 4 documents with respect to each subquery. This what I can, this is the query one. I have converted it into multiple query, but I can say these are subqueries basically. Yeah, correct. And with respect to each one, say this particular, this is say repeated one. This is say repeated one. This is also say repeated one. Or say this is also the repeated one. This is also repeated one. This is also repeated one. So what will happen? It might be possible, say the query one, what is generated, what is it is what it is going to generate. It will be, because I have converted this particular query into the multiple query. So these particular query will be with respect to this one only, because these are generated based upon this particular master query only. Yeah? Correct? Is it fine with everyone? Say I'm having, you can take it in this particular way. This is uh, a man who is having 3 childs. So these 3 childs are having the DNA from this particular man, right? This is the father. These are 3 other sons. Huh? So they are having the DNA matching. It means like a certain portion will be similar. So what I'm getting based upon this particular query, so I will be getting certain common documents. Correct? In each and every query. Is it fine?
Yes.
Okay. So
Yes.
definitely these particular documents which are the repeated one will be taken into the first priority. Yeah? Hmm?
So it
Correct.
will take repeated first one.
Okay, because these are having these are repeated in each and every query, so these will be taken into first one. But say I just need to pass 4 document only to the large language model. So these 6 are repeated. It means I need to take 2 among these 12. First, these 2 are taken. Now I will perform the scoring mechanism. Okay, what are the rest of the 2 documents that I need to select and give it to the large language model? Correct?
Okay, so it is nothing but a rearranging the documents based on queries. So context will not lose.
Yes, you can take it in this particular way. Another, okay, let me talk with respect to the multiple query. Okay.
So are we going to consider the repetitive document over here, like the document which are repeating in every query that are more relevant?
Yes, what I mentioned, these particular repeated documents will be taken into the first priority. So 2 documents plus, or you can take it in this particular way. I'm having, okay, I'm having these 12 documents. I'm having these particular 12 documents. So I will perform the unique. I will perform, I will take the unique docs from it and pass to the large language model, pass to LLM. You can take it in this particular way. So whatever is being selected, I will find out the unique one docs from these particular documents, and we'll pass it to. So at this moment, like we will be having 2 plus 6, 8 documents will be passed to the large language model. 8 docs will be passed to LLM in order to get the output. Correct? Is it fine with everyone? Multiple query.
Please refresh again.
Okay. So what is being
But
happening is,
sir, I think these are 6 documents, na? RR, RR, RR.
I
huh,
think
these are
two
the
one are
repeated
repeated,
one.
which are common, and
Huh.
remaining are six
So
that are
say
not common.
what I can say R underscore one. If, sorry, my mistake. I have written it in this particular way. So this will be the correct one, so that you will be able to understand it.
So repeated one will be two, and remaining will be six, which are
Yes,
not common.
that's what I have
Okay,
mentioned.
okay, okay.
Okay,
So
Correct, correct,
total
correct.
come around it.
okay. So at that moment, like two days which are repeated and rest of the 6 document will be given to the large language model. So total 8 documents will be given to the large language model to perform the output. Okay. So what I have done over here, I was having a query. It will be it was converted into the multiple queries, and it will depend upon us like how many queries I want to have based upon this multiple query technique. So I considered, say, I am going to have 3 queries based upon the given input. So I will do the searching based upon these uh, newly generated queries and say k equal to 4 is that. What I can do, I can check the repeated documents, or what I will do, I will perform the apply the unique onto these particular documents and will try to proceed to get the output from the large language model. Provide these particular documents to the large language model in order to get the output. Correct? Probably you all are having the understanding. If someone is having any doubt, please ask. Hmm. Is it fine with everyone? Say yes or no. Multiple query.
Correct, correct, correct.
Perfect. So over here, like we have seen, say, query rewrite and multiple query. Now we are having another technique, that is RAG fusion. And these are very important things, guys, from the interview perspective. Once you will be going through with the interview, then these particular things are being asked, like how you are going to improve the retrieval. So retrieval, the answer what it will be, retrieval can be improved with the help of 3 techniques. Okay. So first one is query transformation, second one is query routing, and third one is indexing. Once we are talking about query transformation, so first technique is a query rewrite, where we are converting the query into the refined version of it. Second one is the query rewrite, multiple query. So we are, you can say, converting the query into the multiple sub queries, what I can say. And based upon those, the answer is being checked. And now the LLM will be having more context to provide the output. Then third one is RAG fusion, which is very important and it is asked during the interview as well. So it is extension of multiple query, of multiple query. So over here, let me copy this one. RAG multiple query, that is perfectly fine. We are getting these particular documents. Previously, we have passed 8 docs. 8 docs are passed to LLM. To LLM from these particular, you can say, 12 documents. we got 12 documents based upon these particular queries, and we have removed the duplicacy, and 8 unique docs are passed to the large language model. 8 unique docs are passed to the large language model to frame output. Okay, output. That is perfectly fine. But say over here, there are certain documents, say this particular document, doc2 inside the, which is the response of query 3, is having say least relevance. It is having least relevance. And in the same fashion, this particular document over here inside the searching of the query 2, it is also having least relevance. Or what I can say, the relevance score is working over here. So what I will do, I will put a threshold over here. Okay, and based upon that particular threshold, what I can mention over here we will get a list of document for the context, and list of documents for the context, and top 5. Then what you will do, you will apply the ranking based upon the repetition and relevancy score. Okay, so re-ranking is applied. So the documents which are repeated will be having the highest score. Okay, so first the duplicacy will be removed, and the docs which we fetched from the, which we are getting from from uh, the repetition, those will be having the highest score, and then rest of the documents will be selected based upon the relevancy score, and then we will finalize, say we are not going to pass the documents which are having least relevance score. So say I just want to pass, I want to pass 6 docs only. Yeah, let me mention it over here. I I want to pass 6 docs only to LLM. Okay, so what I will do, first of all, like say this document and say this document, these two are say what I have got. I got these particular documents based upon post removing the duplicacy, and these I have selected. I will set it to the highest score. Then I'm going to remove this particular document which are having list score, and then select rest of the 4 document. Those particular document will be given to the large language model in order to provide the answer. In another way, what I can say, it is re-ranking algorithm, or re-ranking stuff, re-ranking. Okay, so initially we got certain rank based upon the relevance, but that is not sufficing over here. What I will do, I will get the unique one which will be having the highest rank. Okay, I will give the highest rank to those particular, you can say, document, and then the based upon the relevance, rest of the document will be selected. And at this moment, I am going to pass a 6 document only. In the previous one, like we have passed a 8 document, but now what I want, I don't want to pass the irrelevant documents to the large language model to provide the output. If irrelevant documents or least score documents are passed, then output will not be correct. Are you able to understand the context what I'm trying to say over here? Is it? Guys, are you able to understand?
So please repeat this one, like fusion.
Okay. So what has happened previously inside the multiple query, whatever I got after performing the search based upon these particular query, I just remove the duplicacy and pass the unique document to the large language model. That was working perfectly, but one issue was there. The documents which have passed, certain documents were having the least score. And as the score was less in those documents, so the output which was formulated based upon these particular documents which are having say list score, 2 or 3 documents probably were having the list score, so output will not be up to the mark. The accuracy will be down in that particular case. So what I'm trying to do, I'm having the another optimized version of it, optimized version of the multiple query. So what I will do over here, I will, along with the docs what I have generated with these particular query, I will do the re-ranking. Okay, and based upon certain threshold, I will try to remove the docs which are not relevant to me in order to share for formulation of the output from the large language side, large language model side. Okay, so I'm passing the relevant document only which are having the higher rank. Irrelevant documents are not passed. Irrelevant means which documents are having less score.
So how we are decide the ranking here?
That we are going to implement. Through practical, you will see how the ranking is being implemented. Let me try to show if
Okay.
that is there, re-ranking or multiple queries. Uh, Writing. Okay. Okay, this is multiple query. Okay, just have a look over here. The question is passed. It is the question is there. It is divided into 3 questions: Q1, Q2, Q3. Then it is going to perform the vector search, and we are having documents. Say 4 documents each. And these are given to the large language model. Like unique one will be, all of these are given, and unique will be considered, and we are able to get the output. Right. This is multiple query. Is it fine? Now, what is being happening over here? Just have a look over here. This is RAG fusion. Whatever the documents what I have got over here, I will perform the I will align the ranking. I will do the ranking over here and then give it to the large language model in order to provide the answer. Probably with the picture you are able to get the understanding. Is it? So how this particular re-ranking is happening? Def docs, docs. Okay, so view score, doc string rank plus k. So this is, you can say, something like which is the formula and all is being utilized in order to, you can say, have the ranking mechanism. We will understand it in more detail once we will be going through with the practical, but we are going to formulate it like which document will be having what score. Okay, so it will be passed from the algorithm, what I can say, or certain formula. We are going to write down the formula that ranking is done in this particular way, and the documents which are having the higher rank will be selected and moved to the large language model. Correct? With the help
Okay.
of this particular diagram, are you able to understand what is ranking or rank fusion? Huh?
Yes.
Okay. So initial question was there. It was divided into multiple questions, multiple queries. Searching is happening, documents are being generated, and then ranking mechanism is being done over here. Okay, we will write the code for that, how this particular ranking will happen, and then give it to the large language model to provide the output. This mind is mimicking the large language model from where we will be able to get the output. Correct? Okay, so there are certain other techniques as well, which are there in order to optimize the retrieval. And tomorrow session we will start with practical from the query rewrite, and then we'll go through with multiple query, then rank fusion, and then we'll discuss rest of the queries. Sorry, techniques in order to optimize it. So that's all for this particular session. If you guys are having any doubt, you can ask. Let me stop
Is,
recording.
is that